Okay, so we can say that if a function has an inverse, then that function is invertible. So a function is invertible if the function has an inverse. Has an inverse. Right. So we know that only one-to-one functions have an inverse function, unlike many-to-one functions which do not have an inverse function. So only one-to-one functions are invertible. So let's consider some function g of x, and this is equal to 2x squared minus 9. Right, so we have this function given, and we want to know if this function has an inverse function. Right, so how do we do this? We have to find out if this function is many-to-one or one-to-one. Right, if it's a many-to-one function, then this function cannot have an inverse. Now we can see that there is an x squared term here, meaning that there is a good chance that there are multiple values of x, or at least two values of x, that gives us the same output. So let's consider x to be equal to 1 and x to be equal to minus 1. Right, so for the case of x is equal to 1, we have g of 1 is equal to 2 times 1 squared minus 9, and this gives us minus 7. Right, and similarly, when x is equal to minus 1, we have g of minus 1. This is 2 times minus 1 squared minus 9, and this also gives us minus 7. Right, so now we can see that for the more than one value of x, we're getting the exact same output. Right, so if we were to have an inverse function, say we have g inverse of x, right, so what does the inverse function do? It will take the output of the function g and give us the input as an output. So let's say we are finding g inverse of minus 7, right? So for the inverse function, when we take minus 7 as an input, what should we get as corresponding x values? Well, we would get either x is equal to 1 or x is equal to minus 1 for minus 7, right? So minus 7 for our inverse function should correspond to multiple outputs, 1 and minus 1, right? But we know that an input cannot give us multiple outputs. That defies the definition of a function, right? So in that case, we cannot have this inverse function. And g of x is many-to-one. It's a many-to-one function. Right, so let's take a look at a different function. Let's say we have h of x, and this is equal to 3 times the square root of 2x plus 1. Right, so now I want to find out if this function has an inverse. Right, so we can see if there are multiple values of x, that gives us the same output. Right, now since there is a square root term, we can find the argument, which is 2x plus 1, and we know that the argument must be non-negative, so it has to be greater than or equal to 0. Right, and from this we can find the domain. So subtracting 1 from both sides and dividing by 2 gives us minus 1 by 2. Right, so all values of x that are greater than or equal to minus half will be in the domain of our function h. Right, and as we input some values of x, and as values of x increases, we see that the function or the output h of x also starts to increase. So this may possibly be a one-to-one function. So if we can try and find the inverse of this function, we can allow h of y to be equal to x. So in this case, h of y is equal to 3 times the square root of 2 y plus 1, and this is equal to x. Now we can just solve this equation for y, right? So we can square both sides. We get 9 times 2y plus 1, and this gives us x squared, right? So we have 9 times 2y plus 1 is equal to x squared. So we have 18y plus 9 is equal to x squared. This gives us 18y. x squared minus 9, divide both sides by 18. So we get y is equal to x squared over 18 minus 9 by 18, which is just half, right? So this should be our inverse function of h of x. Now we can let y to be equal to f of x, and we can consider our f of x to be the inverse function, right? But we can see that in our inverse function, f of x, so this is equal to x squared over 18 minus half, we can see that in this function, we have an x squared term, meaning that there are possibly two values of x that gives us the same output, right? That means that this function would be a many-to-one function, and it shouldn't have an inverse function, right? So if f of x was the inverse of h of x, then we should know that h of f of x should give us x for all values of x that is in the domain of f, right? And similarly, f of h of x should also be equal to x for all values of x that is in the domain of h, right? So these must be satisfied if h and f are inverses of each other. So now we can try and find this. Let's say we try and find the value f of minus 3. We try and find this, right? So when x is equal to minus 3, we have minus 3 squared over 18 minus half. So this is 9 by 18, which is also half, minus half. This is just half minus half, and this is just 0. So f of minus 3 is equal to 0, right? So this should mean that h of f of minus 3 should give us minus 3, right? If we consider x to be minus 3, then we should get x back, which is minus 3. So this is supposed to be x, right? So we can test this, right? So let's see. So for h of f of minus 3, we know that this is equal to 0 from this. So h of 0 is equal to 3 times 2 times 0 plus 1 under the square root. So this just gives us 3, right? So rather than getting minus 3, we got 3, right? So instead of, right, so for this, we ended up getting 3 instead of minus 3, right? So what's going on here? What went wrong? So once again, we started off with and our f of x, which is meant to be our inverse function, was, right? So we have these two functions, right? So we found that h of f of minus 3 gave us 3, right? But we know that h of f of x should give us x, right? So we can try and find this. So h of f of x is equal to 3 times 2 times the function f of x. We have x squared over 18 minus half plus 1. So this gives us 2 divided by 18, so we have x squared over 9. So these two cancel out, and this becomes 9. So we have minus 1 plus 1, right? So this is and this then becomes square root of x squared over 3. The 3 cancels out, and thus h of f of x is equal to the square root of x squared, right? Now we know that the square root of x squared must be equal to x if x is non-negative, right? This is the positive square root, so x has to be non-negative. X has to be greater than or equal to 0, right? So h of f of x can only be equal to x if x is non-negative, if x is greater than or equal to 0. Right? So we need to apply this restriction to our domain of f of x. Right? So we right, so over here we have f of x is equal to x squared over 18 minus half, and in this function at face value we can see that we can take any value of x, right? But we just found from h of f of x that this can only be equal to x if x is non-negative. That means we have to apply this restriction to this function, right? So the domain of f of x has to be non-negative 2. So the domain of f has to be non-negative. So x is an element of the interval from 0 to positive infinity. Right. So now when we take f of 3, so we no longer can take f of minus 3 because minus 3 cannot be in the domain of f. Right. So we can find f of 3. So we have 3 squared over 18 minus half. This gives us 0. So similarly, h of f of 3 is equal to h of 0, and this gives us 3. Right. So now we can say that this function is the inverse function of, where did it go? So right, this function f of x is the inverse function h of x, considering the restriction that for f of x the domain has to be from 0 to positive infinity. Right, we cannot have any negative numbers. All of the numbers in the domain of f of x has to be non-negative. Now, how can we determine from a graph of a function if a function has an inverse or not? Right, so if we're given a graph of some sort of function, let's say we are given the graph of, oops, this is a mess. So let's say we have a graph such as this. Once again, it's a parabola, right? So how can we find from the graph of this function if this function has an inverse or not, right? So once again, we know that only one-to-one functions have an inverse, right? So only one-to-one functions have an inverse. So each value of x has to correspond to a unique output. We cannot have multiple values of x to give us the same output, right? So in order to find whether or not a graph of a function has an inverse, or if the function has an inverse or not from its graph, we can apply a horizontal line test, right? So we can just draw a horizontal line through any value of y. So we can consider any value of y and draw a horizontal line through the graph, right? So say this is for y is equal to a, right? If this horizontal line intersects through the graph at more than one point, so we have an intersection here and another intersection here, right? If the horizontal line intersects through more than one point of the graph, then that graph is not that of a function that has an inverse, right? Because what do we have here? We have a single output. Let's say this is a for two values of x, right? So we have, say, x is equal to a and x is equal to minus a. So for x is equal to minus a and a, we get the same output, right? That means this is a many-to-one function, right? So this is a many-to-one to one function, and that means that this cannot have an inverse. So we can apply the horizontal line test to see if the graph of a function is the graph of a function that has an inverse. Right? If the horizontal line only intersects through one point, say we have a graph like this, right? We only have one intersection, then this is a one-to-one function, and this function has an inverse. Now, when we're graphing a function and its inverse function, so let's consider some function f of x. If we input a into our function, and if we input a to give us b, then we can say that the point a comma b exists on the graph of the function of f of x, right? And similarly, the inverse of this function. So the inverse of this function, what does it do? It inputs the output of function f. So we have b as our input, and it gives us the output a, which is the input of our function f, right? So for the inverse function, the point b comma a exists on the graph of the inverse function, right? So for the original function, the point AB exists on the graph, but for the inverse function, the point BA exists on the graph, right? So the elements just get interchanged, right? So for example, if we say we plot the graph of some function f of x, which ends up looking like this, right? Say this is the graph of some function f of x. Now realistically, this looks like a logarithmic function. Now the inverse of this function will just be a reflection along this line, right? And this line is just equal to, it's just the graph of y is equal to x, right? So if a function has an inverse, then if we draw the graph of that function, if we reflect the graph of that function along this line, then we find the graph of the inverse function, right? So let's say we have this point corresponding to 1, 0, right? So we just reflect this along y is equal to x, and it corresponds to the point 0, 1, right? So remember, if a comma b exists on f of x, then b comma a exists on the graph of f inverse of x, right? So now the graph of this should look something like this, right? So all we did is we just reflected the graph of f of x along y is equal to x, and this gives us f inverse of x, right? Similarly, if we had a point 2, 1 on our original function, then on the inverse function, we would have the point 1, 2,